Hey everyone, and welcome. You know, when we're making games, we spend so much time and energy on making cool things appear in our world. Enemies, items, explosions, you name it. But what about making things disappear? And I don't just mean hiding them, I mean making them gone for good. It's actually a massive part of what makes a game feel dynamic and responsive. So today, we're going to roll up our sleeves and tackle a fundamental skill in Unity: how to destroy game objects. We're going to build a system where our car drives over a package and poof, the package is picked up and vanishes. This is one of those core building blocks you will use constantly, so let's get into it.
Okay, so here's our game plan for this one. We'll start by defining what I'm calling the pickup problem. Then we'll meet our new best friend, the destroy function. After that, I've got a little coding challenge for you to try out. Then, of course, we'll code the solution together step by step. And you'll definitely want to stick around for the end because we're going to solve a classic game dev puzzle that our new code creates, the one package rule. Let's do this.
All right, first up, let's talk about the pickup problem. Before we can start smashing away at the keyboard, we've got to know exactly what we're trying to build. A good solution always starts with a clear problem, so let's set the scene. So take a look at our scene. We've got our car, our fearless driver, and a few packages just scattered around, waiting to be delivered. The goal seems pretty straightforward, right? We drive over a package and we pick it up. But if we hit play right now, yeah, nothing happens. The car just phases right through them like a ghost. That's actually on purpose. Their colliders are set to be triggers. Think of a trigger like a laser tripwire in a spy movie. You can walk right through the laser, but the system knows you did. Our job is to write the code that listens for that tripwire event and then actually does something about it. Now you might be thinking, okay, to make it disappear, can't we just make it invisible? And yeah, you absolutely could. You could just find its sprite renderer component and turn it off. But here's the catch. That's like having a ghost in your game. The package is still there, it's still taking up memory, its collider is still in the world, and any scripts on it might still be running in the background. It's just invisible. For our game, that's not what we want. Once a package is picked up, it's gone. We don't need it anymore. We want to completely remove it, to destroy it, and free up all those resources.
And that brings us to the star of today's show. To properly get rid of game objects, Unity gives us the perfect tool for the job. This built-in function is your go-to command for cleaning up your scene while the game is running.
Meet the destroy function. Its purpose is beautifully simple. It completely and utterly removes a game object from your scene. I'm talking about everything associated with it. The sprite, the physics components, the colliders, any scripts attached to it, the whole shebang. It's literally the code equivalent of selecting that object in your hierarchy and just slamming the delete key. Poof, gone. So how do we use this powerful command? Well, when you call the destroy function, you need to give it some instructions inside the parentheses. These are called arguments. The first one, and this is non-negotiable, is what object are we destroying? You have to be super specific and give it a direct reference. You can't just yell, destroy a package, into the code. You have to point right at it and say, destroy that one. The second argument you can give it is a delay time, which is just a number in seconds that tells Unity to wait before it carries out the order. And here's a really cool and important tip. That delay is totally optional. If you just tell destroy what to get rid of, and that's it, it'll happen instantly. Or more accurately, at the end of the current frame. But adding that delay, oh, that's where you get all the creative control. Think about it. An enemy explodes, and you want the explosion animation to play for half a second before the enemy object actually gets deleted from the game. That's what the delay is for. It gives your game that extra bit of polish and feel. Okay, theory time is officially over. You've seen the tool, you know what it does. Now it's time for you to get on the keyboard and put it into practice. I've got a little challenge for you. So here's the challenge. Can you write the C# code that will make our package disappear a moment after the car drives over it? Think about where this code needs to live and what information you'll need to feed into that destroy function. And here are the specific rules of the game. Number 1, you have to destroy the exact package you collide with, not any other one. 2, add a short delay before it vanishes. Don't make it disappear instantly. 3, and this is a big one for good coding habits, use a variable to control that delay time. Don't just hard code a number like 0.5 into the function. Trust me, this will make your life so much easier later. And finally, rule 4, make that delay variable show up in the Unity inspector so you can change it on the fly without ever having to open your code editor again. So go ahead, hit pause, jump into Unity, and give it your best shot. We'll be right here when you get back. All right, welcome back. Awesome job giving that a try.
Whether you completely nailed it or got a little stuck somewhere, it's all part of the learning process. Now, let's walk through the solution together, piece by piece.
First things first, where in the world does this code even go? We're going to put it in our driver script, inside a very special Unity method called onTriggerEnter2D. Now, this method is kind of magic. You never have to call it yourself. Unity is always watching. The moment our car's collider touches another collider that's set to be a trigger, like our package, bam, Unity automatically finds and runs whatever code we've put inside this method. And see that collider 2D other part? That's Unity handing us a gift. It's a direct link to the collider of the other object we just run into. Next up, let's create our variable for the delay. We'll add this line up at the top of our script with our other variables. Now pay close attention to this little bit of text in the square brackets, serialized field. This thing is one of the most useful attributes in Unity. It lets us keep our variable private to this script, which is great for organization and preventing bugs, but it also tells Unity, hey, even though this is private, please show it to me in the inspector. It's the best of both worlds. So we declare it as a float, which is a number with a decimal point. We name it destroy delay, and we'll give it a default value of half a second, or 0.5f. That little f just tells C# that this is a float specifically. And now, for the main event. We go inside our onTriggerEnter2D method, and we add the line that does all the work. We call destroy. For the first argument, what to destroy, we use other.gameObject. Remember, that other variable Unity gave us is just the collider of the package. We don't want to destroy just the collider, we want to destroy the entire game object it's attached to. So we use .gameObject to get to it. For the second argument, the delay, we just pass in our shiny new destroyDelay variable. And that's it. That's the core logic.
And check this out. This is the payoff for using serialized field. We save our script, we hop back over to the Unity editor, and if we select our player object and look at our driver script in the inspector, look at that! There's a new field called destroy delay with our default value of 0.5 right there. This is a massive deal for your workflow. Now, you or a designer on your team can play the game, decide that half a second feels a bit too slow, and just type in 0.2 and hit play again to test it instantly. No more digging through code to change one little number. It's fantastic. Okay, moment of truth. Let's hit play and test our code. We drive over a package, there's the short delay, and poof, it's gone. Excellent. Let's try the next one. Drive over it, and it's gone too. Uh-oh, wait a minute. Our code works, but it might be working a little too well. We've accidentally turned our car into a package hoover, sucking up everything it touches. For our game design, we're supposed to be a delivery driver who can only carry one package at a time. We've just introduced a new logic problem. So, how do we fix it? This brings us to a really important concept in programming called state management. Right now, our code has no memory. Its entire worldview is, if I touch a package, destroy it. That's all it knows. We need to give our script a brain. It needs to be able to track its own state. Specifically, it needs to answer the question, am I already carrying a package? We have to check this state before we even try to pick up another one. The simplest, most elegant way to handle a simple yes or no state like this is with a Boolean variable, often called a bool for short. Think of it like a light switch. It can only ever be in one of two states, on or off, true or false. It's perfect for what we need. So let's head back to the top of our script and declare a new variable. Bool has package equals false. We'll initialize it to false because, obviously, when the game starts, our car isn't carrying anything yet. Okay, we've installed our light switch. Now we need to actually wire it into our logic. We're going to go back down to that if statement inside onTriggerEnter2D. Right now, it only asks one question. Did I just hit an object with the tag package? We're going to make it smarter. We're going to make it ask two questions. Did I hit a package, and is my has package light switch currently in the off position? And here's what that looks like in code. We modify our if statement. We use the and operator. That's just code speak for and. It means both conditions on either side of it absolutely must be true for the code inside to run. The first condition is the same as before. The second condition is not has package. That little exclamation mark is the logical not operator. It essentially flips the value of a Boolean. So not has package is a very common, clean shorthand for saying if has package is not true, which of course means if has package is false. Now we have arrived at the final, most crucial step, and I'm telling you this is one of the most common bugs beginner programmers make, so burn this into your brain. If our if statement is true, meaning we found a package and we don't already have one, and we pick it up, what's the very next thing we need to do? we have to flip our light switch. Inside the if block, right after we call destroy, we must add the line has package equals true. This updates our state. It tells our car's brain, okay, you're now carrying a package. If you forget this line, the switch will always be off and our logic won't work. All right, let's hit play and see our finished logic in action. We drive up to the first package, we make contact, and it gets picked up and destroyed. Perfect. And silently, in the background, our has package variable has just been flipped to true. Now for the real test. We drive over to the second package and, look at that, nothing happens. We just drive right through it. Our logic is working perfectly. The game checks the if statement, sees that has package is true, which makes the not has package condition false, and the whole thing just says nope and skips the pickup code. Success. And there you have it. You've just mastered a truly core concept in game development. Not just the destroy function, which you will use absolutely everywhere, but also the basics of state management with Boolean flags. Think about it. Every time an enemy explodes in a cloud of smoke, or a bullet hits a wall and vanishes, or you collect a coin and it disappears with a satisfying bling, that's almost certainly a destroy function doing the work. So now that you have this power in your toolkit, what are you going to build? What kind of cool mechanics can you dream up now that you know how to make things disappear on command?